Hello, everyone. I'm happy to be here to try to talk about how PFAS research can be used in support of policy. A little bit of a disclaimer here. I've never been a policymaker. I've always been a scientist, doing it myself, directing it, leading it, managing it. But often I was leading the support for science that was problem solving, that could be used to help determine policy. So how do we get busy? Why do we start talking about policy, or how do people, the policymakers, get involved? First of all, there's got to be some outrage. And that can be from the news, from headlines, it can be in your social media, it can be on TV, and that can generate widespread concern. And when a lot of people begin to be concerned about something, often it's because they're hearing that they may be exposed, or they know that they're being exposed to something. Just think of air pollution. Or there can also be suspected harm, sometimes proven harm. Dollars also are a big driver here. If it turns out that it's going to be really expensive to clean something up, that may slow down a policy determination. On the other hand, it may make it happen faster so that the harm doesn't get any worse. And this can be driven by an economic analysis, or it can be driven, for example, by the market basket, where people just decide that they don't want a certain kind of product anymore because of something that's in it. Occasionally, a single new scientific finding will get a policy discussion started, but usually it's the accumulation of information. And sometimes this can lead to regulations. So if we talk about what's happening and what are some of these headlines, I've just pulled out a couple examples, some from here in Rhode Island within the past year, that are toxic PFAS are found in many places in Rhode Island, and actually, especially in our drinking water here in Rhode Island, and regulations are being developed for that. Not in place yet, but under development. Well, Rhode Island is not alone. We have contaminated communities across the United States, and here are just a couple of headlines. Whether it's researchers find unsafe levels of these chemicals, and industrial chemicals here, or PFAS in their drinking water, or widespread contamination, or we have Senator Gilliland calling for public health assessment, for example, in Hoosick Falls. This kind of work will drive, this kind of information will drive the policymakers to begin to be considering certain issues. So an example of this has happened this summer in Colorado, where PFAS were found in almost every surface water system in that mountain state, and found in some drinking water systems. Because of that, the Colorado Department of Public Health and the Environment developed an action plan where they collected samples of drinking water from across the state, and they found that at least 10 of their systems exceeded what is the EPA advisory level, and many of them, actually 10, exceeded what is Vermont's level for 20 parts per trillion for a sum of PFAS. They found that the levels, for example, of one PFAS, PFHXS, were egregious in an area near Peterson Air Force Base. And then they found that the Water Control Commission actually has proposed a PFAS policy which calls for the review of PFAS levels as a class by 2025. Well, here are some other headlines that are coming about. We tend to focus on PFAS in drinking water. So, for example, in my state of North Carolina, Chemours, which makes PFAS, is being looked at and dealt with by the state because of the Gen X pollution that they've caused in our drinking water. But we're finding that there are issues related to the ocean, our forever chemicals harming ocean life. And we found, for example, that Michigan has sued the DuPont company, a major producer of PFAS, and that lawsuit is actually moving through the courts. But the point I want to make here is that PFAS are also in other places. Our exposure can also be from food packaging and food itself. And maybe you here in Rhode Island, some of you probably go up north to ski in New Hampshire, Vermont, Maine, or maybe you go out west. But the point is that PFAS have been used in the ski masks, especially that used in racing, Nordic racing. And the point is the ski community is beginning to back off using it in those places because it has led to contamination. Now, I'm not going to spend any time talking about all the different kinds of PFAS. I think here in the STEEP program, you are aware that PFAS are a huge class. I just want to make the point that just a few years ago, I was saying there were 4,700 of these, and then 5,000. But EPA is now reporting that there are over 7,000 of these PFAS that are intentionally made. And then there are many more that are unintentional byproducts of industrial processes or atmospheric degradation of some of the precursor kinds of compounds. So I think that's just something to be aware of. And we know that some of the PFAS that are used, for example, like the fluorotelomere alcohols that are used in many products, actually lead to stable PFAS, whether, for example, it's PFOA or PFOS or some of the others. And it's important to understand that polymers, fluorinated polymers, I'll make the comment that we're being told that, well, they're not going to break down in the environment. Oh, well, that may be true. Do we really want more styrofoam being produced that we're going to be dealing with hundreds of thousands or millions of years from now? But it's important that some of the fluorinated polymers, first of all, you have the life cycle, so you have to use precursors to make the polymers, and there's always some escape. You have some of these polymers break down. For example, some of the side chains can break down to release PFAS with really, really super long half-lives. And there are additives, for example, that are other kinds of PFAS that may be used in the production of polymers. And again, these can escape. So the life cycle is something to consider. So new PFAS are being found all the time. And in a paper this summer in Science, there were two real important papers, one coming from EPA's laboratory in North Carolina, and the other was a policy statement that was done by a bunch of policy people talking about it. But this chlorinated PFAS, it's an ether linkage, was produced under, basically EPA could know what they were producing, but nobody else could basically. And these compounds were produced by Solvay. They got released into the environment in southern New Jersey. And guess what? They were found as far away as New Hampshire. So a new PFAS that we didn't know about before, we now can find is out there in production and is in our soils and in the water. So how are we being exposed to PFAS? Well, for example, we have PFAS exposure being produced by industry. There are essentially no naturally occurring PFAS. There are a few microorganisms that can make the chlorine-fluorine bond. They are few, they're far between, there are not many of them. So these are industrial products. And they are put into a variety of consumer products for multiple uses. They are also put into air firefighting foam, which has been used to fight fires, and I'll come back to that. And then they get released into the environment. From the environment, they have the opportunity to expose not only our wildlife, but they expose people. And we know that these are even transferred to infants through breast milk and actually in utero. We can find it in cord blood, and we now have evidence that they transit the placenta. So again, how are we exposed from these industrial agents? Well, again, these have been used in consumer products since the 1950s. And they are now a contaminant in drinking water, which I've already mentioned, but in a whole variety of products to provide stain proofing to carpets and fabrics, and provide stain proofing, I should say, as well as as things don't leak from food. Many of us have in the past enjoyed our Teflon pots and pans, which I know I don't use anymore. We also, for example, have PFAS in our clothing to help us get rid of stains, and it's in a lot of cardboard packaging as well. This is just a partial list. And as I mentioned, the air firefighting foam. What I want to point out is much of our concern and studies have focused on ingestion of PFAS, whether it's from food or from drinking water. But we now know that in fact there can also be inhalation, especially to some of the newer PFAS, and there may be even some dermal exposure occurring as well. So when we talk about drinking water contamination, the first study coming out reported there were 6 million Americans that were exposed to PFAS in their drinking water, of follow-up study by the Environmental Working Group, which had more sensitive levels of detection, and this was focused just on two of our major legacy PFAS, PFOA and PFOS. In this case, that there were more than 110 million Americans, a third of our population, are drinking water the level exceeds EPA's advisory level, health advisory of 70 parts per trillion, the sum of PFOA and PFOS. And that's not looking at any of the other thousands of PFAS that could be in our drinking water. And we know that if you're near, for example, an industrial site, whether it's production of PFAS or use of PFAS, there's higher levels of PFAS in the water. The same thing is if you're near a place where the AFFF is being used, and that could be in airports, or it could be in areas where there are military or just regular firefighting areas. Many of our fire stations have high levels of PFAS. And also we're finding it, and this is something of growing concern, that we're finding it coming out of our wastewater treatment plants into water, which is then, for example, used in agriculture or potentially even in drinking water for further downstream. So does all this exposure in water actually have an effect? Well, we have data that's coming out from near the Academy, the Air Force Academy in Colorado and Peterson Air Force Base. And what you find here is the well water in this area is contaminated by the PFAS explicitly or especially that was used in the AFFF. So what's interesting is AFFF often has PFOS, sometimes even PFOA, but in this case, the AFFF used in this area was PFHXS, and you can see there's a 1,000-fold difference in the median levels in people in this area compared to US median levels. So higher exposure because of the use of AFFF. And then a great study that was reported by Gloria Post of New Jersey Department of Environmental Protection, who is a real expert when it comes to PFOA, is that as the levels of PFOA go up in the drinking water, the levels of PFOA in your blood rise at the same time. And this is something that we have to focus on. So PFAS contamination in North Carolina has a clear example of a regrettable replacement. So in the 1980s, for example, Gen X, which was a replacement for PFOA, it's called a short chain. It was supposed to have a short half-life, which it does in people, but not in the environment, began to be detected. The plant in Fayetteville, that's the home of Fort Bragg, by the way, but it's also where Chemours, which was spun off from DuPont in about 2009 was, they began to use high levels of Gen X and release it directly into the environment. And that was first reported in 2016, where it was found in the not only in the Cape Fear River, which is the river that runs from Fayetteville down to Wilmington, North Carolina, but also in the drinking water. And about 6 months after that was reported, the North Carolina Department of Environmental Quality regulated that no longer could Chemours be releasing Gen X directly into the river. And so that led to a decrease. If you just look at the river, though, and its some of the cities upon it, I want to mention that Bynum, which is upstream of Fayetteville, where the Chemours plant is, also has very high levels of contamination in the Hall River, which is a tributary to the Cape Fear, and that's because of wastewater discharge from Burlington and Greensboro, which are cities upstream of Bynum on the level. So it's important to realize that. So if we look in Wilmington, I've told you that Wilmington's water is contaminated from things that were released from Chemours. What they found, and Jane Hoppin and colleagues from North Carolina State and several other universities in North Carolina actually went down and recruited hundreds of people from Wilmington and measured what was in their blood. And I think what's important is that they found that the levels of many of the compounds, which were persistent in the blood of people, the naphthalene byproduct, the PFO4OA and the PFO5 DOA are like Gen X. They're PFAS, they're fluorinated ether compounds, and what you can see is that in fact these levels were detected in the blood of people in Wilmington, as well as some of them are in US blood. The levels go down slightly as the levels of the as after the regulation was enforced in North Carolina, but they're still there and they are very persistent. And naphthalene byproduct 2 is not intentionally produced. It's an unwanted byproduct that occurs, and it's getting into people. If you look at some of the legacies, the PFHXS, what you see is because of the contamination coming downstream from possibly as far as Bynum or upstream on the Hall River, but certainly from the Keymoors plant, what we are seeing here is elevated levels in the people in, for example, North Carolina. And what we see is that they're higher, for example, than the US population as well. So that's the water story. But what about fast food packaging? Well, a study a couple of years ago looked at over 200 different kinds of fast food packaging and found in over a third of them that PFAS were present, whether it was dessert and bread wrappers or sandwich and burger wrappers and so on. And predominantly what they found were PFOA and PFHXA, PFBS, which is a short chain, and 6,2-fluoroethylamyl sulfonate. The important thing is this study was done using something called PIGGY, which is measuring total fluorine, and they went in then and took about 20 of these 200 samples and actually determined what was in them. So there's a lot that we don't know that's in the food packaging. And if you another study looked at over 130 different products for total fluorine, and again, they found that all the molded fiber products that they looked at had high levels of fluorine. This had a direct impact because, for example, Whole Foods, it turned out their mobile fiber compostable containers they were using that you could take home with food in it had PFAS. And within a month or so, they had gotten rid of those and put in something that was PFAS free. But there are some products that you can get, such as bamboo and clay-coated products and so on, that have no or little fluorine. So the serum concentrations of PFAS have been linked to the use of food packaging in the general US population. So for example, as you have more prepackaged or fast food that you're eating, your levels of PFOS and PFHXS go up pretty rapidly. And then, for example, so fast food exposure does increase your exposure to PFAS. And so does seafood consumption. I can tell you that here in North Carolina, contamination with PFOA of fish in the Cape Fear River have been detected as early as 2007. But for example, recent studies coming from the Faroe Islands show that children who eat more whale meat have higher levels of PFAS in their blood, and that, for example, so do children who eat more shellfish. And we all have PFAS in our body. This is not a chemical that only some people are involved to. More than 98% of people in the US have measurable amounts of PFAS. So the levels of PFOA and PFAS have declined following phase outs. And you can see that really with PFOA and PFOS, whose phase out really started in the early 2000s, kind of completing production in intentional production in about 2015. But if you look at some of the others, there's really no change. So levels have decreased for some of the ones that were our first ones to raise concern, PFDA and PFOA and PFOS, kind of plateaued now. They may not be going down anymore, and that may be related to recycling in the environment as well as production from other precursors. But a point I want to make is almost everything we know about humans and these compounds is based upon what we measure in the blood. And there's only been one good study that's looked at cadavers, and this was actually from Catalonia in Spain. And I think what I wanted to point out is if you look at some of the, say, the short chains, where you find the PFAS is different than where you find the PFOA or the PFOS. So for example, PFBA and PFHXA, those are short chains. They're highest in the lungs. But we also find that in some of them, for example, PFHXA and PFNA, we find that they're in the brain. And I think this is something which we really need more information, because are we really getting a good total or a good idea of how people are really being exposed? So our PFAS exposure concerns really began in about the 1960s. I mean, this is really not something that should have come as a surprise to most of us. They were first made in the production, some Teflon was invented in the 30s, and then PFOS and PFOA began to be produced for nonstick coating and industrial uses in the 40s and the 50s, and it started increasing the amount. I think what's important is that by the 1970s, there was evidence that PFOA was having adverse health effects in monkeys, including actually killing them, certainly affecting their livers. And around the same time, PFAS were being detected in the serum of workers. Again, the use of these things continued, more was being made, and then by the late 80s, we knew that PFOA could cause cancer in rat studies. At least there were some studies. And shortly after that, 3M, which was one of the major producers of PFAS, PFOS and PFOA, began to monitor PFOA, for example, in their workers. And all along, there were workers who were reporting adverse health effects. In fact, pregnant women were removed from the line, for example, in the DuPont plant in Parkersburg, West Virginia. I've already mentioned Chemours began action and as a spinoff in North Carolina, for example. I think one thing that's really important is that the immune effects began being reported in about 2012. That was in people. We've known for at least 20 years that they were immunosuppressive in experimental animals. And some of us are beginning to ask, is some of the enhanced susceptibility to COVID maybe related to the PFAS levels that people have? In 2006, EPA invited the 8 major producers to phase out PFOA. PFOS had solely been produced intentionally by 3M, and they had voluntarily agreed to stop making PFOS in about 2002. But I should point out that's because they used other PFAS in their processes. So we know we have exposure, and now we're beginning to know that we have health effects. None of you have to go measure this laundry list of health effects, but the point that this slide is trying to get is we're not looking at one effect in one tissue, in one sex of one species. In fact, these both animal and multiple animal species and human studies show a very wide range of health effects related to PFOS and PFOA. So I think that we have to realize is that these chemicals can do many, many different things in different tissues as well. And some recent impactful studies that were done directly to address some regulatory needs was NTP conducted guideline studies of 7 PFAS. These were really more the legacy ones and the short chains, both the sulfonates and the carboxylates. And what they really found out was it doesn't matter whether they're long chain or short chain, they all do the same thing. The amount you deliver may vary. In other words, you may have to give a bigger administered dose, but the effects are similar. And then just this year, NTP published the results of their peer-reviewed rat cancer study, where they found that in the rats, they got both pancreatic and hepatic tumors at extremely low doses. And this has had a direct effect, and I'll come back to it later, at least in California. So PFAS do a multitude, cause a lot of different effects, and they do it by activating a number of different pathways in the cell. So on this slide, we can see that PFAS activate the PPARs, which is a nuclear receptor in reporter cells as well as in vivo. But a point I want to make is it's not just PPAR alpha. It's also PPAR gamma. And gamma is the one that plays a major role in adipogenesis and also bone formation, and is a key player in diabetes. But it's not just the PPARs that are activated. On the next slide, there are other mechanisms that can cause PFAS toxicity. And here I'm just going to remind you of the complexity that we're dealing with PFAS and why they in some ways are much more difficult to deal with than, say, the dioxin-like chemicals, which have a sole initiating mode of action, which is activation of the AH receptor. Here with PFAS, they inhibit fatty acid transport, they can interfere with mitochondrial function, and they work with multiple receptors, not just PPARs. They can interact with the AH receptor, with CAR, PXR, FXR, maybe even more. So you have a plethora of effects by multiple mechanisms that can be involved. So if we're studying PFAS exposure, this has been done in several human populations, and I think one of the most important ones for policy determination was the C8 study, which was really a study of the PFOA contamination because of the DuPont plant in Parkersburg, West Virginia, which led to contamination of the land and the drinking water of people in the Parkersburg area as well as parts of Ohio. And this was actually went to court, and there was a suit where the judge established a 3-member science panel to look at the data. Recruited over 67,000 people, measured blood levels, got health effects in these populations, and concluded that there were at least 6 highly associated effects because of this PFOA exposure: cancer, high blood pressure, ulcerative colitis, high cholesterol, and many others. There were indications, but they weren't as strong as these 6. This whole study has led to a lot of publicity, and this can lead to policy determinations. First, there was the documentary that occurred that was on cable news networks called The Devil We Know, which was looking at this contamination in Parkersburg. And just last year, I think it was November of 2019, the big screen movie was released where Mark Ruffalo played Rob Billitt, who was the lead attorney, who was the one who doggedly looked at the contamination in Parkersburg, West Virginia. And if you haven't seen it, I'd strongly encourage you to take a look at it. The movie is really very, very accurate. I was very pleased when I saw it. So again, just to remind you that PFAS is a multi-system toxicant affecting lots of our different organ systems and tissues at different life stages. So I've already kind of alluded to this question about replacement PFAS being more or less toxic. Some work coming out of Sue Fenton's lab showed that GenX did essentially the same things as PFOA at essentially the same dose, or within a factor of 2. The same hepatic effects, the same low birth weight, impacts on mammary gland development. Studies showing the same kind of situation in zebrafish were published recently, and a study that just came out, again from the EPA laboratory in North Carolina, showed that Naphthalene byproduct 2, that's one of those molecules that's present in the blood of people in North Carolina, bioaccumulates and is toxic to the liver in mice. Then there was a paper that came out a few years ago looking at the fluorotelomere alcohol, the carboxylic acid, and the sulfonic acid, and again, cause cell inflammation and death in mice. And then the NTP studies that I already mentioned, where the C4 sulfonate and the C6 carboxylic acid increased liver weights and enzymes. It caused liver lesions, also impacted thyroid hormones, just like PFOS and PFOA. So in response to this, the NTP, in response to all this information, working with EPA, developed a project called REACT, where they are looking at least 150 different PFAS chemicals, trying to screen them in vitro approaches and computational approaches to try to understand, can they group them in any way? Are they all doing the same kind of thing in health? Are they causing the same kind of health effects? And this will help them to focus research and also do mixture studies going forward. I should mention they're also looking at 10 different firefighting foams that the military is currently using. Don't know what's in them, but we're busy testing them. So I think that this is important, and this will have direct policy implications as well. So we have some conclusions. We are all exposed to PFAS. Frankly, there are too many PFAS to do proper toxicity testing, including that of mixtures. And PFAS are all likely to be not only persistent, remember they're these forever chemicals, but they are also going to be mobile in the environment and on a life cycle basis. So we begin to need to ask the questions. We need to prevent new problems or worsening of existing problems by limiting uses that aren't really essential. Once we've got the PFAS contamination, it's much more difficult to try to clean it up. So we have some key problem-solving research questions I'd like to pose. First of all, are we measuring 90% of the PFAS in our samples or only 10%? And we need to know that whether we're dealing with drinking water, whether we're dealing with food, or whether we're dealing with what's in our bodies. And the answer is we really don't know that answer yet. Some of the studies are saying we may only be looking at 20, 30, 40% of what's in us. We need to begin to ask the question, when do we really need to use these chemicals? Are there some essential use, or are there safer alternatives? Not just an alternative, but an alternative that would be safer. And I think that's really a question we have to be asking. And then I think when we talk about policy, we're going to have to ask, do we want to address PFAS as a single class, or do we want to make them into subclasses? So I've already alluded to the fact that pilot data suggests large increase in unidentified PFAS in drinking water. And this is kind of consistent with production trends. So the fact is that we're seeing alternative PFAS, things that we don't know or are being produced. We don't know what they are. In the Cape Fear River, I know Mark Striner of EPA has said that they can only identify 20 to 25% of the PFAS in the river, and they are monitoring for about 45 different PFAS. So I think this is a real question we need to deal with. So can we take a class approach to PFAS? Well, there are really too many PFAS to do proper toxicity testing, including we really have just begun to look at the issue of mixtures here. So the CPSC actually charged the national academies a few years ago to look at whether they could treat organohalogen flame retardants that were used in consumer products as a class. And the academies came back and strongly endorsed the use of subclasses of organohalogens and said that an approach that uses subclasses to assess the chemicals is scientifically justifiable. This would have huge implications for research and, again, eventually for policy. And a paper on which I was a co-author that just came out about 2 months ago actually proposes a class approach for regulatory decision-making. I've already mentioned at the beginning how economic analysis helps to inform policy, and you have two things to look at here. How much does it cost when you don't act, as opposed to how much will action cost? And action is not only cleanup and remediation, action or the economic analysis is also what about the health effects? So estimates have been made for remediation. New Hampshire is looking at this issue right now to clean up their contamination. And there are a number of scientists and scientific groups looking at the issue of, well, how much does hypertension, how much does elevated cholesterol, how much does cancer cost in the population in association with exposures? And that will help inform policy decisions. Policy can also be impacted on this next slide by meetings and reports. So, for example, the National Academies opines, and that has an impact. For example, the International Agency for Research on Cancer, which is part of WHO as well as other parts of WHO, their reports have large impact. We have many international groups that have meetings and reports on this. I think some of you may be aware of the ATSDR report that came, the draft was released in 2018 with a quite low level of concern and looked at several different PFAS in this case, and that is still in draft form, but people are using it. NTP does do highly regarded reports, such as the report on carcinogens, and their systematic reviews that are very useful. And then I want to mention that that EFSA, the European Food Safety Agency, just September 17th, released its risk assessment of PFAS in foods, and they looked at 4 different PFAS in the sum total. And if you calculate what that would be in terms of drinking water, the sum of those 4, their total daily intake would be about 3 parts per trillion in drinking water. Obviously, legislation also impacts policy. So just last year, a whole additional list of PFAS are shown on this next slide, were added to the toxic release inventory by legislation in the National Defense Authorization Act. And these will have to be reported by EPA starting in next July. Another important one was when the reauthorization of the FAA that occurred a year and a half ago removed a requirement to have PFAS in air firefighting foams. So no longer is that a requirement. And I should let you know that for years, major European airports such as Heathwick, Arlanda, and Sweden have not been using PFAS containing AFFF. They're satisfied with the use of detergent containing AFFFs as well. So what are our U.S. regulations that we have on PFAS? Well, EPA has none. They say they're working on them. It's been going on for a while. In 2016, they released a lifetime health advisory of 70 for either alone or the sum of PFOA and PFOS. They have no regulation of groundwater, and they still have not made a determination that PFAS or PFOA is a hazardous substance. This is frustrating. FDA does have some regulations I'll mention in food contamination, and the Department of Defense several years ago actually moved in the right direction. They still require PFAS in their AFFF for example, an oil fire on a ship, but in all their training, they're no longer using PFAS containing AFFF. And CPSC has some regulations that they're developing. So just the very end of July, FDA announced an agreement with for the required phase out of 15 food contact materials which contain the 6,2-fluorotelmer alcohols. Now, the important thing is here, this came out of studies in their own laboratories where their scientists were able to show that the 6,2-FTOH was metabolized to a 5,3 polyfluorotelomere carboxylic acid, not just the C6 PFCA, which had been reported and was the basis really for a lack of regulation. This molecule is highly persistent, it's toxic, and the companies that use these 15 food contact materials will no longer be making them within 3 years. And this FDA in the past has regulated 7 other PFAS that can be used or can no longer be used in food packaging. And our states are taking the lead. And I think it's important to realize we don't always rely on federal regulations. On this next slide, we have what's happening in the states. So we have the New York State ban, which was passed by the State House and Senate and would become effective in this, 2023 when Governor Cuomo signs it, hopefully. San Francisco has restricted the chemicals in foodware as of this past year. Maine has banned the intentional addition of PFAS in food packaging, as is Washington State, and Denmark is the first country to ban PFAS in food packaging as of this past summer. So, in part because of a lack of federal action in regulation of PFAS, states are moving ahead, and you can see the states on this, largely Minnesota, Michigan, many states on the East Coast, California. Again, many are states where contamination has been a problem, raising the level of concern in the populations. They're moving forward, and I wanted to mention the California Water Board, which Cal EPA acted immediately on the NTP findings of the pancreatic cancer in the rats and concluded that PFAS are a serious public health threat and at very, very low levels, and that they needed a class approach, and there is significant contamination in California. Because the Cali PA calculations were that 0.1 parts per trillion, PFOA would be associated with a 1 in a million cancer risk based on the NTP studies. The California Water Board now notifies users who have levels around 10 parts per billion PFOA that their water may be contaminated. So some of the states have actually set maximum contaminant levels for PFAS. So for example, Michigan just this summer set the most stringent levels for, I think it's 7 different PFAS up here, including Gen X and PFBS, some of your short chains. But for example, their level for PFNA they set was only 6. New Hampshire has set stringent levels, as has New Jersey. The strictest really are coming from neighbor states. Vermont, where a sum of 6 PFAS is associated with the maximum contaminant level being 20 parts per trillion. The same level is set for PFH, in Massachusetts for 4 of them. So I think that our states are moving ahead. There are still no regulations related to groundwater. There are guidance levels in several states as well. So what does a junior scientist need to do to impact policy? Number 1, don't be afraid to make a mistake. And these are just some examples of a mistake I made over 30 years ago when I was still much more junior. And I was studying PFDA. But my concern was, is it dioxin-like? And after I did several studies and I concluded, no, it wasn't dioxin-like, even though it did have all kinds of adverse health effects, I decided, no, I wasn't interested in that because at that time, I was focused almost exclusively on TCDD and related compounds. So that was a mistake that I made, not serious in the long run. So you need to talk to people. You need to talk to policymakers. That's one thing, but you need to communicate your findings to people so they can understand them. It's not enough just to publish your science. It's not enough just to talk to other scientists. You have to get out there and get involved with communities. Remember, communities live in the environments. They're the ones being exposed. They have ideas of what their concerns are, and you need to be able to communicate them in a language that they can understand. You can't just talk science. You have to talk American. It's important to impact policy that you do research that addresses key problems that regulators may be having. And in order to do a lot of this, science today is very multidisciplinary and transdisciplinary. You have to collaborate with other people to expand your own knowledge and to have a broader impact. And again, don't be afraid to take risks. We learn from failure. So with that, I'll say thank you all for listening. This is a picture from Parkersburg, West Virginia, the site of the DuPont plant that contaminated the Ohio River with large amounts of PFOA. I want to thanks to all my trainees and colleagues for the past 40 years or more, and stress with all of you, never hesitate to ask questions. Thank you.